What's going on, everyone? Welcome back. Patrick here, and in this next video what we got to do is take these inequalities here and then solve them. Notice that they're all absolute value inequalities because they have these functions within absolute values. Now, just in general, notice that what's happening here is we either have a function within an absolute value that is greater than or equal to a number, or we have a function that is less than or equal to some kind of number, right? And this number, a, is basically any real number. Now, notice that in the first two, that number a, it is positive. And then notice in the last two that a is negative. And what we're going to focus on first is if that a value here is positive. So these two examples. If it's negative, then the cases are a little bit more unique. They're special cases, and we'll discuss them later on as the video progresses. So if we're looking at something like this here, and then that a value is positive, the way that you solve these, the way that you get the solutions, is you pretty much want to just split up this inequality into two separate inequalities, and you would split it up as taking the function being greater than that a value, so pretty much just getting rid of the absolute value signs, or finding out when the negative function is greater than or equal to that a value. And then same thing over here. You either find out when the function is less than or equal to the a value, or when the negative function is less than or equal to the a value. And some textbooks, some profs may actually show this a little bit differently. And so as we progress through the questions, I'll show you other ways that this can be presented. But ultimately, whichever way you do it, it leads to the same answer. Now, again, I want to make a point that this here, this rule, only applies when this a value is positive. When it's negative, then these cases are going to be different. And so notice with number one, we have the absolute value of 6x minus 4 is greater than or equal to 5. So notice that that's this format over here. The a value is greater than 0. And so I'm just going to erase this here. Taking this and rewriting it here, basically we have absolute value of 6x minus 4. So notice that that function is 6x minus 4. And we're finding out when is it greater than or equal to 5. Well, we split it up like this. We find out when is 6x minus 4 greater than or equal to 5, or when is negative 6x minus 4 greater than or equal to 5, like that. Right? So we just went from here to here. Another thing I want to mention is that this same rule applies if it's just greater than a, then these would just be greater than a. So that's not going to make a huge difference. So this could have just been greater than 5. This would just be greater than 5. This would be greater than 5. Right? Same thing here. If this was just less than, then these would just be less than. So whether it's a greater than or equal to, or just a greater than, it really doesn't make a huge difference. So just wanted to mention that. All of these here are either less than or equal to or greater than or equal to, but they could have also been greater than or just less than signs, and the process would be exactly the same. And so from here, what happens is once you have these inequalities, notice the absolute value went away, you just isolate for that x. So you solve them as regular inequalities. So we'll have 6x is greater than or equal to negative 4 plus, when you bring the negative 4 over, it becomes a positive 4, so we'd have 9. Divide both sides by 6, and we'd have x is greater than or equal to 9 over 6, which is 3 over 2. Over here, what we would do is distribute the negative in, like that. And then personally, what I do is when I'm isolating for the x, I bring over the x's to the side where that coefficient is going to be positive. So notice we have a negative 6x, so we'll bring it over. and we'd end up with positive 6x. Bring the 5 over, 4 minus 5 would give us negative 1. And so when we divide here, we don't have to worry about flipping that sign, right? And so that's the other solution. So either x has to be greater than or equal to 3 over 2, or x has to be less than or equal to negative 1 over 6. And that's the solution for this over here. And we could represent it in different ways. So on a number line, we could say x is either greater than or equal to 3 over 2. It's including it, so that's a solid dot right there. If it wasn't including it, if it was just a greater than sign here, then that would be an open dot. But this is including the 3 over 2. So it's here, and then x can be less than negative 1 over 6 as well. So this would be negative 1 over 6, and it would go that way, all the x values less than that. In interval notation, we can say it's either from negative infinity to negative 1 over 6, including a, so we would put a square bracket there, or from 3 over 2, including it, so square bracket, to positive infinity. Right, so you could represent it in that interval notation as well. Now, what I want to mention here is that this is the way that I personally do it. If that a value is positive, I just split it up like this, because the reason why I like to do it is because I don't have to worry about flipping this sign here, right? Notice that the sign is staying the same. All we're doing is we're putting an f of x and a negative f of x, an f of x and a negative f of x. But another way that you may see this shown for this particular case is you may see, instead of having the negative here, if you at this point divide by negative 1, notice you'd end up with 6x minus 4, but because you're dividing by a negative, you would have to flip that sign, and then you'd have a negative 5 like that. And it makes intuitive sense if you just look at this over here. So let's think about this. The absolute value of something, this expression, has to be greater than or equal to 5. Well, it's obvious that if this here is greater than or equal to 5, then it's going to satisfy this, right? If this here ends up being, let's say, positive 6 or positive 7, positive 8, positive 100, it's going to satisfy that inequality. But if you think about it also, because there's an absolute value here, this here, this expression could, for example, be negative 8 as well. Because if this ends up being negative 8, the absolute value of negative 8 ends up being positive 8, which is greater than or equal to 5. And so if you think about it, this 6x minus 4 can also be less than or equal to negative 5. Because if it's less than or equal to negative 5, like I said, whether it's negative 6, negative 7, negative 8, negative 100, when you take the absolute value, that's going to turn to a positive, and that's going to be greater than 5. And so a lot of times you'll see this case being split up like this. Instead of being split up like this, they'll say f of x is greater than or equal to a, which is this. But instead of writing it like this, they'll say f of x is less than or equal to negative a. Now, personally, I don't like to do it that way, because notice how now you got to worry about flipping that sign and then extra positives and negatives. I'd rather just keep it like this, personally. But some textbooks, some profs may take this case and split it up like this. And then this case is not going to be the same if we're dealing with the absolute value of f of x is less than or equal to a. I'm going to go over that case as well in the second question, and that's another reason why I don't like doing it this way, is because notice how it's just so consistent between both cases. All we have to worry about is the f of x and the negative f of x, so we don't have to memorize as many things, versus if we're splitting it up into these two cases like that. Right? So just wanted to mention that you may see it shown like this or like this, so like this or like this, but if you solve both of these, you'd get the same solutions. All right, so that is the answer to number 1. Now with number 2, what's going to happen is it's going to be this case right here, because notice we have the absolute value of a function is less than or equal to 7. So what we would do, we have to find out when is that function less than or equal to 7, or when is the negative of that function less than or equal to 7. And so if you work on solving them, what would happen is you bring the 2 over, so we'd have 3x is less than or equal to 5, divide both sides by 3. So x is less than or equal to 5 over 3. 3, sorry. There's one solution. And then over here, bring the negative in. Now again, you could divide both sides by -1 at this point, but then because you'd be dividing by negative, you gotta remember to flip that sign. So personally, I'm just gonna go about it like this, and then I'll bring the negative 3x over. That'll turn into a positive 3x. Then I'll bring the 7 over. -2 minus 7 gives us -9. Divide both sides by 3. And so we'd end up with x being greater than or equal to -3. And so in this case, notice that x is either less than or equal to 5 over 3, but it has to be greater than or equal to -3. And so notice that we can combine those in this case. And that's a big difference between this case and this case. Notice here the solutions were on the end of the number line, versus with this number line, it's going to be in the middle, right? Because x has to be greater than or equal to -3, but less than or equal to 5 over 3. So if we combine it, that's how it would look like combined, right? So it's between two x values, versus here it's on the ends of two x values. So on a number line, if we show this, we'll have 5 over 3 over here, we'll have -3, and it's inclusive of the ends. If this was less than 7, then you'd end up just having a less than sign, so these would be open dots then, right? But because it's inclusive of those ends, these are closed dots, and it beat all the x values in between here. And then you could test your solution. You could pick x values in between. So let's say we pick 0. If we plug in 0 over here, 3 times 0 is 0, plus 2 is 2. Absolute value of 2 is 2, and 2 is less than or equal to 7. Versus here, with the first one, notice that 0 is not within the solution. So if we plug in 0 here, notice 6 times 0 is 0, minus 4 is -4. The absolute value of -4 is +4, but notice +4 is not greater than or equal to 5. So 0 in this case, we could see visually it's not in the solutions, and we could test it as well. And we don't just have to pick 0, you could pick any numbers here, you could pick any numbers over here. Right, so that's how we would represent that solution. And then in interval notation, you'd represent it like that. Right, so notice that with these two cases, remember that this is for when the a is positive, the number lines, the solutions, look very different. Now, in terms of how this can generally be shown, so again, this is the way that I personally do it. I work with these separately and then I combine them, right? And I do f of x and negative f of x, and then I keep the sign the same. But another way that, I'm just going to erase all this actually. Another way you'll see this case sometimes shown in certain textbooks is they'll say f of x is less than or equal to a certain value, and then instead of having the negative here, they'll divide both sides by negative, but then you got to flip the sign, so then they'll say f of x is greater than or equal to negative a. But if you think about it, if a is positive, if f of x is greater than or equal to negative a, but it's less than or equal to positive a, well, you can combine these like that. And so they won't show them separately like they do with this one, because this one, it is two separate ones. You can't really combine them. Versus here with this one, you can combine these into one double inequality. And so they won't really show this. I just wanted to show it as a step to get to over here. And so again, you can do it like this, solve them separately, and then combine the answer into a double inequality. Or you can just start off with a double inequality initially. Again, they'll sometimes show it like this. And so if we took this, which is in this format, and we applied it this way, what would happen is the a is 7, so we'd have negative 7. This function is greater than or equal to negative 7, but less than or equal to positive 7. And then you would just solve this like a double inequality like we've done in previous videos. And the solution that you would get to this would be the solution that we got before. I actually forget what it was now. I think it was like negative 3. X is greater than or equal to negative 3, but less than or equal to positive 5 over 3. That's what we got as the solution. If you solve this double inequality, you'd end up with that same solution versus doing it separately like this. But again, personally, I like to do it that way. And more so that the reason why I like to do it that way is because, again, I don't have to memorize as many of these sort of formats depending on what this is. All I have to remember is if it's in this format and that a is positive, you could always just split it up like this and just making sure that you keep the signs the same. And then you just have f of x, negative f of x, solve from there. All right, so just wanted to go over different ways that you may run into examples or how examples are solved in your book on these. But yeah, whichever way you do it, just make sure you're getting these exact same solutions. Now, we went over the case where the a is positive, right, which was for these two. But what if that a is negative, like in these two cases here? And so what I'm first going to do is give a general rule. It's actually the solutions for both of these is very easy. It's very quick. It's just you got to kind of remember it, and we're going to intuitively go through why that is. So those cases we did before was when a was positive. Now, what if a is negative? What would happen? Well, if this a is negative, right, if it's a negative number, when is the absolute value of something going to be greater than a negative number? Well, it's always going to happen. The absolute value of anything is always going to be greater than or equal to 0. Right? No matter what it is. It could be 0. If you get 0 here, the absolute value is 0, 0. But if you get a negative number, then that's going to change to a positive number. If you get a positive number, it's going to stay a positive number. And so if you get something like this over here, when is a certain function, when is the absolute value of a certain function greater than or equal to a negative number? Well, it's always going to be that. And so the answer to this is always going to be x can be any real number. Or in interval notation, x can be from negative infinity to positive infinity. And so that's the answer to number 3. And it could have been any negative number here, and it could have been any function over here. And you could test it. You could plug in any x value here, any real number for this x, 0, all the way from negative infinity to positive infinity, including 0. And you'll see that no matter what you plug in after you take the absolute value of that, it's always going to be greater than or equal to negative 5. right? So if you run into something like this where that a is negative, then this is the solution. It's always going to be XCR. X can be anything. Versus here, what's this going to be if the a is negative? Well, notice that the absolute value of anything can't be, it always has to be, as we said, greater than or equal to 0, right? It always has to be 0 or positive. And so it can't be negative. And something less than a negative number would be more negative numbers, and it's impossible for that to happen. And so in this specific case, there's actually no solution ever if that a is negative and this is a less than or equal to sign. Right? So the answer to number 4 is that there's no solution. Because no matter what you plug in here for x, this side here is always going to be 0 or positive, and 0 or a positive number is never less than or equal to -7. Right? So there's no x value that would satisfy this inequality, and so there's no solution. And just in general, it's this. So this could have been any negative number. This could have been any function over here. There's not going to be a solution. So just wanted to go over those cases. They're quicker cases. It's just you got to remember if that a value is negative, it's going to be one of these. But if it's positive, then there's going to be more work to get those solutions.